Hey everybody, welcome to the next set of videos. We are going to be talking about square roots and the Pythagorean theorem. We are going to start off just talking about square roots, what they are, and try to make some sense out of those, because later on when we do talk about the Pythagorean theorem, you will need to know what square roots are. My goal here in these next videos is to kind of chunk it down to give you smaller pieces at a time so that they're not dragging on to like 20-30 minute videos, because if that's hard for me, then I know that that's hard for you. So I'm going to try to reduce the time just by doing little bits of content. So there'll be more videos and it'll be the same amount of stuff, but they'll be chunked down into smaller bits at a time. Let's get started with square roots. The first thing you're going to do is a drawing exercise. So I want you to draw as many different rectangles as possible for each area. Not squares, rectangles. So that can include squares. Imagine, for example, this 4 square units. You have 4 little, these are not exactly squares, but imagine you have 4 little blocks, okay? And I want you to arrange them in as many ways as possible to have a rectangle. So one simple example here, I'll just do the first one for you, is I have 1, 2, 3, 4 all arranged like that. That's a rectangle. What else can you come up with? So do that for 4, 6, 8, 9, 12, 16, and 20, and I challenge you to get as many of them as you can. Go ahead and pause the video and get started with that right now. Okay, so let's see. We're going to go through one by one and we'll see if you got them all. 4 square units. This is what I came up with. So I already showed you this one, arranging 1, 2, 3, 4 like that. Okay. You could also do it vertically. I know it's the same thing, but you know, a wide rectangle versus a tall rectangle, let's pretend they're different. So that's a learning lesson for the next ones. And you could also have a square, perfect square. 1, 2, and 2 by 2. Nice. Anything else? Nope. Just those 3 variations. Let's try the next one. 6 square units. You go straight down 6, straight across 6. Oh, look, there's even an extra. So we have a 2 by 3 and we have a 3 by 2 rectangle. All right, that's 6. 8 square units. 8 down, 8 across. We can do a 2 by 4, 4 by 2. Yep. Still 4 different possibilities here. Now we're getting to the 9. 9 square units. You can go 9 across, 9 down. And hey, we're down to 3 again. A 3 by 3 perfect square. Now we're over to 12. 12 across, 12 down. I have a 2 by 6, a 6 by 2. Anything else? Oh yeah, look at that. 1, 2, 3, 4 by 3. 4 by 3 and a 3 by 4. Oh, so there's quite a few variations there. Now we're on to 16. There must be more, right? 16 across, 16 down. I've got a 4 by 4, and I've got a 2 by 8 and an 8 by 2. Okay. All right. Last one, I believe, 20 square units is the last one I asked you to do. 20 across, 20 down. I've got a 2 by 10, a 10 by 2, and I've got a 5 by 4 and a 4 by 5. So those are all the possibilities for 20. Okay, so now some quick questions to recap here. We've done all of these. I just put them up here for reference. For how many of the numbers that we did here, 4, 6, 8, how many could you make perfect squares? And by perfect squares, what I mean is the side lengths are all perfectly exactly the same. So, for example, the first one we had was 4. We had a 2 by 2, so it's a perfect square. So this one's a perfect square. What else? 6? Nope. 8? Nope. 9? Yes, that was a perfect square. 12? Nope. 16? Yes, 16 was a 4 by 4. 20? No. So we have 4, 9, and 16 as the perfect squares here. Okay, and what are the side lengths of each of the squares you made? Well, the side lengths, we're talking about, I say square here, so I'm talking about the perfect squares, so the 4, 9, and 16. So for the 4, it had a side length of 2. For the 9, it had a side length of 3. For the 16, it had a side length of 4. Interesting. They're increasing like that. Wonder if that's important. How is the side length of a square related to its area? So in this 2 by 2 example here of our square, how is the side length, the length of this side right here, the 2, how is it related to the area? So there are 4 things on the inside, 2 here and 2 here. Well, you should know this. You should know that area is length times width. So really, if what I'm doing is trying to find the area here, then I'm just doing 2 times 2. So that's how it's related. The side length determines what's going to be inside of it. 2 by 2 fills out that whole area. What do the perfect squares have in common? Well, these side lengths are the same. Side lengths are equivalent. That just means that they're equal to each other. 2 and 2, right? Instead of 2 and 3 or 5 and 4. Those would be not equivalent. These ones are. What do the non-perfect squares have in common? Well, I guess you can say that they have different ways to, let me go back. We can look at a few here. They have many different possibilities of how to form rectangles, but none of them are perfect squares. What do they have in common? They can all be multiplied by 1 and its number itself, and most of them can be broken down into smaller bits. Like here we have 20 that's broken down to 1 times something, 2 times something, and 4 times something, right? And 5 times something. So you can break them down into smaller rectangles, but the side lengths will not be identical. Whoops, I'm jumping ahead here. Will not be identical because they're not perfect squares. Okay, so I know that's a lot of stuff, but you can just write that here. Side lengths are not equal, and they only form rectangles. That's what you could write. Okay, I'm not going to write that all here. We have 2 more real quick things here. Show that 49 is a square number. And if you want to challenge yourself here, you can pause the video and give that one a shot. There's another one right after 2. A square has an area of 196 centimeters squared. What is the side length? If you want to challenge yourself, go ahead and pause the video and do that. Otherwise, continue on, and I'll just go through these ones real quick. 49 is a square number because these side lengths would be 7 and 7. I can do 7 times 7 equals 49, and because the side lengths are the same, it's a square number. A square has an area of 196 centimeters squared, so that means that if I had a rectangle here, the interior would be 196 blocks, and we're trying to find out what the length of the sides could be. All right, and the other important information is it's a square, and because it's a square, I know that both of these sides are equal. So it's going to be something times another of that something. All right, 196. What can I multiply by itself to get 196? It turns out to be, I don't know. Let's count it up. So if there's 196 blocks here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can double check it here. I know you can see my calculator here if you don't believe me. 14 times 14 is equal to 196. Let's double check that over here on the calculator. 14 times 14 is equal to 196. Okay? And that just shows you the relationship between the sides and the area. All right. And that is the end of the first video. Hopefully that's a little bit shorter and you can understand this little bit. If you don't, then please ask questions.